it's easier than it looks to graph a secant or cosecant function. That's the black swoopy thing that's coming in from the top and bottom of this graph right here. But all you have to do is think about this not as secant or cosecant, but as cosine or sine, right? If you remember the relationship between secant and cosecant and sine and cosine, you have a sine or cosine curve that looks like this, right? I'm not doing a great job drawing this thing, but you get the idea. Everywhere the sine curve has a minimum, then that points to a maximum on the cosecant curve, and likewise throughout this whole thing. Okay, so I'm going to point to those spots right there and say if we could only figure out the equation of this red curve that I just drew, the sine or cosine function, we'd know everything we need to make it into a secant or cosecant function. So let's do this. We've got, my favorite thing to start off with is the value of the midline. I think it's very easy. And if you look at the maximum value right there and the minimum value right here on the sine wave, it looks like it's going to be halfway in between these 2 points. We've got -5 on the low end and +1 on the high end. Okay, so what's halfway between those things? Well, you just complete this little algebra here, and it's going to be 1/2 times -4, so that's -2. That's the midline, that's k. And next we'll find the amplitude, which is how far do you have to go from this midline to get to the maximum of the curve right there. That's the amplitude. And you can see graphically, the amplitude is going to be equal to 3. Right? So there's amplitude, there's k. That was very quick. In terms of these other pieces, we're going to have to talk about the period of this function. And if you look at any 2 points, how long it takes to repeat the curve, say right here, that's at -3 pi, and right here, that's at 0, that's a distance of 3 pi. Now, you could have done it differently. You could have said from this point at -3 pi over 2 to this point at +3 pi over 2. That's also a distance of 3 pi. Okay, so that's p, and that's equal to 3 pi. So what I'm going to do to calculate the next portion of that equation is say p equals 3 pi. And if you remember what p equals as a formula, it's 2 pi over b. Okay, so if we calculate this one, this is going to be, let's see, my pi's cancel out, and I'm going to multiply each side by b and divide each side by 3. So I get b equals 2/3. Now I have checked off just about every variable I need. I've got a, I've got b, I've got k. Okay, I just need h. H is the phase shift. So where is the phase shift of, and first off, we're focusing on sine curves. Okay, so you have to find the sine curve within this larger function that we've just drawn here. And I'm going to clean this up a little bit. So where is the starting point of this sine curve? Let me get rid of those dots too, because I'm going to use a dot for the starting point. I would say a good sine curve is starting, oh, I don't know, here, right? It's on the midline at -2, and it goes up from there. So because of the clumsy way I drew this graph, really the midline crossing should be right here, okay? And that's going to be at, well, it's between pi over 2 and pi, so that's going to be 3 pi over 4, right? 3/4 pi. So that's all I have to do. I just say from there, h equals 3/4 pi. Okay, so now we put it all into an equation, and I'm going to erase parts and then drop the respective values in. I've got the amplitude of 3. I've got the b value of 2/3. I've got an h value of 3 pi over 4, which I'm going to squeeze in there, and then a k value of -2. Okay, so that's my equation with a sine wave. Now I said all that's different about the black curves that we're trying to model and the red curve that I drew is we scribble out sine and we replace it with its reciprocal, cosecant. So there's our equation. It's 3 cosecant of 2/3 x minus 3 pi over 4 minus 2. Okay, and that's it. Now for the cosine function, that's not so bad. We've already got most of the work done, right? K is staying the same, A is staying the same, B is staying the same. The only thing that's going to change here is H. So let's erase some of these things. And in green, I'm going to put the values for the cosine function. That's going to be, no, green is not showing up well. Let's try something better. Give me some purple. 3 cosine, 2/3, that's the B value, that doesn't change. And -2 is my K value, that doesn't change. The only thing that does change is where does the cosine function start? And I'm going to say this cosine function starts, just to mix it up a little. Let's pick this one over here. That looks like a good starting point for a cosine curve at -3 pi over 2. So this is going to be positive 3 pi over 2 in the parentheses. Remember, we have that sign flip right there. And now the only thing that I have to change is turn the cosine into a secant function, and I have described not the red wave. That was what I was using as a guidepost. With the secant function, I'm describing these purple curves right here. This guy, that swoop right there, this guy swooping right there, and so on and so on and so on. I haven't talked about the asymptotes of a secant cosecant function yet, but those you just pick graphically. Like here's an asymptote right here, here's another one over there. You can see they're going to be midline crossings of their own. They're going to cross that imaginary sine or cosine wave at its midline. And you can find them if you really need to by taking the average of this point and this point. That's going to be the location of an asymptote, right? They are regularly spaced just the same way as any other key feature on these trig functions.